This is problem 14-120. The slotted plate of the figure below has an angular velocity of 15 radians per second and an angular acceleration of 5 radians per second squared, both clockwise. The slider C has a constant speed relative to the slot of U equal to 100 millimeters per second. If A equals 200 millimeters and theta equals 20 degrees, determine the absolute velocity V sub C and the absolute acceleration A sub C of the slider. Repeat for a counterclockwise angular velocity and angular acceleration. Okay, this problem is very similar, of course, to the ones we've done before, where there is an angular velocity, but now we're going to also add an angular acceleration. So hopefully by now, if you have been following along with the previous problems, you should have a pretty good idea where this is going as far as which terms are now going to have 0 values and which term is now going to have a non-zero value. So let's just jump right into the math. All right, so let's look at our givens. We have our omega, our angular velocity, is equal to 15 radians per second. But this is in the clockwise direction, so it's negative 15, and the axis is in the k hat direction, right? And then now we have an alpha that is non-zero, and this is 5 radians per second squared, but also clockwise, so negative, also in the k hat direction, and radians per second squared. Okay, and this is slider C. So it's actually the angled slot at the top of the disk. And there is the pin, okay, the slider, and then the U motion is in the same direction as the slot, okay? So let's go ahead and talk about that. Well, the motion vector U is going to have a velocity that has 2 components now. And so we need to know what the angle is of this slot, because there's going to be an I hat and J hat component, or more appropriately, an E hat X and an E hat Y component, okay? So how are we going to figure this out? Well, they do tell us that the theta is equal to 20 degrees. All right, so if the velocity vector U, the magnitude is equal to 100 millimeters per second, then the actual vector itself, so if I redraw the U vector without the magnitude symbols, it's going to equal 100, but going to be times negative cosine 20 degrees E hat X plus sine 20 degrees E hat Y. Okay, hopefully this is obvious by this point how the trig works for this. Opposite, adjacent for the X and Y components. Okay, so ask me if you need clarification on that, but that is going to be the vector value of the velocity of the slider running through the slot at the angle of theta relative to the rotating axis of the lowercase x and the lowercase y. All right, so there, just as a quick little reminder, there's an x and a y direction that is rotating with. Oops, and I'm already messed that up, and that's okay. I like you to see that these kinds of concepts matter. I should be drawing the x this way, the y, which is why I have the theta. Okay, this axis is going to rotate along with the disk. Okay, so as far as the math, let's find the velocity of slider C. Well, the velocity of the origin, as usual, is going to be 0. And then we'll have plus the angular velocity crossed with the distance of slider C relative to O. This is going to be a non-zero value, because they did tell us, and I didn't finish the known values here, that we're going to have a position of 200 millimeters in the A direction. Well, which way is the A direction? The A direction is, let me get rid of some of this clutter. is going to be up from the origin O. Okay, so this is the height A. But it is, I guess it's implied that the slider is starting a distance 0 in the horizontal from the origin. I don't feel like the question is explicitly saying that to us, but the drawing is implying that the slider is in the 0 in the x, but is a distance a in the y of 200 millimeters. Okay, so now that means that we know that we do have a distance. So this omega cross r is not going to be 0, right? Plus the velocity of c relative to the rotating axis, right? And we just found that that is u. So this vector and this vector are the same value. Okay, so let's actually throw some numbers in here. So we got 0 plus, and then we have negative 15 k hat crossed with 200 e hat sub y. Okay, and then we have the vector u, 100 times negative cosine 20 degrees e hat x, it's supposed to be an x, plus sine 20 degrees e hat y. Okay, pardon my penmanship. Sometimes it's a little tough writing on this tablet. Okay, this adds up to be 2,906 e hat x, okay, plus 34.2 e hat y. Okay, so we have a velocity vector kind of up and to the left. Okay, so the velocity vector that we just calculated, give it a color, is like kind of like that. Maybe that's a little too close to 45 degrees. But that's the general direction, okay? All right, so now let's do the acceleration. So the acceleration vector of c is going to be equal to the acceleration of the origin, which is 0, okay, plus the angular acceleration vector crossed with the r vector of c relative to O, which is not 0. Okay, then we have the angular velocity crossed with the angular velocity crossed with the position of c relative to O, also non-zero. Okay, plus the acceleration of c relative to the rotating axis. Okay, well, do they give us a value for that? I would say that the slider is being told to us to be at a constant speed relative to the slot. So this is a 0 term. All right, then we have the final term plus 2 times the angular velocity, okay, crossed with the velocity of c relative to the rotating axis. Okay, so that is going to be a non-zero term as well. All right, so let's start filling in the values. So a sub c is equal to 0 plus the angular velocity given is negative 5 k hat, and then crossed with 200 e hat y. That is the position. Okay, then the next term is going to be the omega. So omega across r is going to be negative 15. So I'm going to write that here, negative 15 k hat crossed with 200 e hat y. Okay, and then that is going to turn into, well, 3,000 e hat x. But first, let me put the first omega again. So negative 15 k hat, all right, crossed with the answer to this, negative 15 k hat crossed with 200 e hat y, which is 3,000. And then that's going to be e hat x. Okay, and then plus 0, and then plus 2 times negative 15 k hat crossed with the velocity that was given to us. So the velocity of c, not given to us, sorry, the velocity that we end up calculating, that is the 100 cosine 20 and the sine 100 sine 20. So if you didn't calculate that, you can double, or if you did calculate that, then you can double check. It should be 93.97 e hat x plus 34.2 e hat y. All right, so the final answer, which is quite a bit of math here, so make sure you're practicing, is 2026 e hat x minus 42,181 e hat y, and this is millimeters per second squared. And that is the answer. Okay, so I consider that the analysis complete. And I would like you to try and do this problem with the repeat for counterclockwise angular velocity, angular acceleration. So the final answer for that is going to be the velocity vector of c is going to equal negative 3,094. Sorry, my computer is running really slow, so it's not writing completely nice. 94 e hat x, okay, plus 34.2 e hat y, right? And then the answer for the acceleration is negative 2026 e hat x minus 47,820 e hat y. Okay, so when you're doing these problems, the setup is important. The understanding of what numbers go into what terms is important. And then getting your answer and kind of trying to make sense of it so you can build an intuition as to how the motions might actually behave is also important as well. And this is after you've found the answer.